All right, so I'm gonna go get started here without wasting any time. We've got a lot packed into 30 minutes, and I'm really honored that you would invest your morning or afternoon or evening, depending on where you are in the world, to hear about these generative pre-trained models, these foundation models, these large language models, and why they work, how they work, why they don't work, and what we do about it practically in the enterprise. So thank you for joining. I'm Noble. I'm a technical leader, product leader, focused on operationalizing emergent technologies. Currently, I lead product and some applied science application integration at a company called Ventera Corporation in Northern Virginia in the US. I've been a digital software practitioner for about 20 years, about 2 decades, and I'm a huge proponent of ethical data use, responsible use and delivery of AI and data trust. A lot of what I speak about sort of falls under the data trust umbrella, things that we can do to afford the trust of the users that use it, which is a great business goal, because you want more users to use your thing. You want to have more loyalty with your product, and that comes with being ethical in how we handle the data behind this stuff. So lots to cover today on one of such topics. All right, so today we're going to cover a couple things. I'm going to use a fun way to sort of emphasize why these large language models behave unpredictably and what the impacts of that is. I call that the llamas, and I'll explain why I call it that. I thought that was clever when I came up with this acronym. But then we're going to go through a very high level how large language models work, why they're unreliable. I'm going to switch to a Jupyter Notebook where I show how we mitigate some of these. And hopefully in about 25 minutes, we can sort of land the plane with some key takeaways. And if you have questions, I would love to hear you. Looks like we've got quite a few folks in here. So let's start with my best presenter impersonation and welcome you to the llamas. What are llamas? These are I call them the Lion Language Model Awards. And this would be the inaugural ones. Lying meaning you ask it something and you don't know if it's telling the truth or not. And so welcome, and you're in the audience here, and I'm glad you're here. All right, so the first one of the major things, unreliability features, I guess, or issues with rather of large language models are, we hear a lot about hallucinations, confabulation, things that it might spit out that might be untrue. But more importantly, one impact to the real world, at least in the US and perhaps where you are in the corner of the world that you are, is misinformation and disinformation. And within this past year, when I started putting this presentation together, a lot has happened. So some of this content is probably really old, and there's a lot on misinformation and disinformation from large language models that have happened. One such thing was, if you remember, in the US around May, the stock market tanked. There was a scare because a couple of reliable news sources reported an explosion near the Pentagon, close by where I live. And that got debunked, market restored. But that was just a taste at the time that made people start thinking about some of the issues that could come. All right, so that's misinformation, disinformation. Next one is also on the It's mostly on calibrating our trust or the lack thereof with some of these tools. Often we over-index on trusting the things that we learn from some of these large language models because we've been using AI, frankly, for a while, and in ways that are not as hands-on, or at least that we use within the last year or so since Bard and ChatGPT came out. If you remember an attorney, or call him the lazy lawyer, don't sue me, please, used ChatGPT to write a legal brief, which he filed in court. He cited 6 cases that never existed. And if you've been following this space even lightly, you've probably heard of Peter Luduca, who's probably now been disbarred, but I'm not too sure about that. All right, so, and then because I get the pleasure of speaking to you today, the first place, in my view, of large language models being unreliable is what actually birthed this entire talk. I wrote a post for Towards Data Science, which I'll link at the end of this post, where I asked, I ego surfed, right? I asked, tell me about Noble Ackerson, and I found out I was dead. Hilarious story. I'm not going to get into the details too much, but only to say that in an alternate universe, I'm actually not speaking to you. I'm actually already dead. I co-founded, I'm a social activist, apparently. I built a smart jump rope. I did a transportation app in Ghana, West Africa. And it's actually very familiar. If you start thinking about some of these things, it's just mixing some truths in green, highlighted in green. I'm sorry if you're colorblind. I didn't really think about that until now. But I did co-found a startup called LinksFit. However, it wasn't about jump ropes. I've never lived in New Jersey, nor am I from New Jersey. I was born in the UK. I'm by heritage from Ghana, so there are half-truths in there somewhere. Advocate for diversity as well. And it's very, that's the definition of misinformation or disinformation, if you think about it, or even malinformation, because it's very hard to tell what's true and what's not. And if you are unfortunate, like an attorney, that you might get embarrassed, you might actually lose customers if you're in the business of it. So that's basically how I want to sort of set the stage here today. And then there's whenever I make this presentation, I get the notion that, oh, well, this is, this presentation was back in May March of this year of 2023. I get the pushback is these things are young. But around the time that I posted this, Bing had already integrated ChatGPT into Bing Chat and the like. So I don't really buy it. And what's more is that, in preparing for this, one of the state-of-the-art open source models came out, and I did the same thing. I actually do this with every single large language model that I get my hands on, to ask it about myself, not because I have an ego or anything. It's just, I know what's true and what's not true about me more, hopefully, than anyone else. And so if it does choose to respond, I want to hear, or want to sort of see what it says. And for my research, I want to understand, how it got to that output. So this is a Llama 2, which was released a few weeks back. And it gets, I'm apparently now a CEO of a company called Bubble. For full disclosure, this company does not exist. I'm very philanthropic, and I kind of want to meet my alternate self. I am really a human. I have 2 kids. I live in Virginia. In case you're wondering who I am, that's me right there in the middle. So what do I mean by unreliable? And I'm going to try to answer this question through the traditional way, a very high level way of sort of a machine learning life cycle, right? You get an input, you go through a data transformation process, and you get a classification, recommendation, prediction, summarization, what have you, some sort of product output. Okay. For the system inputs, things that we have to look out for, things that we've seen in out in the field that sort of light the flare on unreliability are, data leakage issues, fairness and bias issues, and data privacy concerns. You may have heard some school districts are banning banning ChatGPT in their systems or Bard in their systems. It's not scalable, but that's what they choose to do. And some corporations choose to do the same. Samsung notably decided to ban use of, proprietary proprietary generative AI systems because of the fear of data leakage. Most mature companies have also put out some policies around putting, protected health information or personally identifiable information. So that's the system input, things that could, lead to some sort of unreliability within your coffers, within your company. Within training and evaluation, what causes them to be unreliable? That fairness and bias thing comes up, but also what we call hallucinations. I like to call them confabulations, because it's actually closer to in the canonical sense. There's some safety issues, again, data privacy and data leakage. And you might see these as footnotes or at least warnings on a lot of these popular closed source chat tuned language models as well. And then last is sort of the inference time, where we're moving towards sort of an output, things that are of concern in reliability or the lack thereof is, paying attention to regulatory issue, safety, and again, confabulations. We actually, consumers mostly, see the issues regarding large language model reliability during the system output phase, or at least the product output phase. So you've heard a lot about these things. I wanted to take a beat to define these, and I created this visual. Hopefully it makes sense. You've probably seen a lot of definitions of foundation models, generative AI, large language models. There are, let me sort of go through these. So a foundation model is essentially a general purpose AI technology, whereas a large language model powered product has a defined use case, performs specific tasks. Perhaps they can be tuned for chat or long conversations. They can be tuned for instruction. They can be tuned for in different ways, right? So essentially here, you can have a foundation model that's just for text, which is mostly what we've seen so far. You're going to start, and also for images like Stable Diffusion, the corpus behind that is, instead of text, tokenized text, is actually tokenized bytes of images, or maybe video, or maybe audio. There's also more tuned foundation models that are focused on augmenting data for the sake of, differential privacy, or just I know Gretel AI just recently released one of those, and they focus on synthetic data. There's geospatial data sets. IBM and NASA a couple days ago just released their foundation model, and it goes on and on. Bloomberg has their foundation model focused on financial data, that kind of stuff. But all in all, they just either fall into the text, the image, or the audio, image, or video. Generative AI, on the other hand, is sort of inherits from foundation models, and large language models can be used interchangeably with foundation models and generative AI. I just want to qualify that. But for developers in the audience here, LLM based you can basically work with them by either talking to them directly, make to an API call that you sort of hook up yourself, if it's open source, or if it's closed source, like Anthropic's Claude or Cohere or OpenAI's API, you can actually sort of work with it directly, or you can bring it within your VPC, your virtual private network, and be able to sort of train it on your data for specific tasks. And we're going to see some of that today, hopefully, if we have time. And so non-LLM based systems, then we start getting into multimodal. So Google's Bard recently updated their conversational chatbot, their rival to ChatGPT, to include images. And you know, in my view, the more inputs, input modalities that you include, when these things fail, they fail very hard, and they become twice as unreliable if they're doing images, because they might fail the input or the inference of what an image is using Lens. In the case of Google, could go wrong, and then now you have an added complexity of a potential confabulation or hallucination issue when you're trying to turn image to text for an output. So that's pretty much it. Just to summarize here, I'm not going to go through everyone. I think I pretty much classified this, but large language models are autoregressive, and all that is a fancy word for they're stochastic, or they're just random. They're just predicting the meaning of the next word, and that comes into play a lot as to why they don't work, and I'll tap into that later. So using foundation models, or LLMs, whatever you want to call it, are possible through a couple innovations from some brilliant minds. In 2017, Google released a paper, Attention is All We Need, where they announced something in the paper, talked about something called the attention mechanism. And with the attention-based approach, our model is paying attention to different parts of the input when processing data. This is overly simplified. Example being is you're reading this slide here, and you start looking at this meme, and you see it's as hilarious as I think it is. So essentially, that's what transformers do. They start paying attention to the thing that's on the, you know, that's coming before, what's coming after, and you know, acts on that, right? I'm also very proud of this meme when I thought of it. And for those who don't get it, please, you know, I'd love to hear you chat amongst yourself to try to figure out what it means. All right, so how are these large language models trained? A quick beat on that. So training is, you know, complex yet simple. I don't know how to put it. In some cases, it's scored on basically scoring a rank list of probable guesses of the next word. Like I said before, if it's just a word, it will be represented by a token, or a byte if it's like a non-language based model, as I showed you on the previous slide. And it as you're training, you're increasing or decreasing based on the understanding of the input. And the data is trained. This is a big part, is like, how do they train these? Like, with what kind of data? They train it on academic content that's like legal, patents. We're talking medical journals, that kind of stuff. It also trains on general internet. It basically sweeps out. You've heard about Twitter and Reddit sort of locking down things just so that some of these large companies can't just get data for free. They also train on novels, books, you know, there's something called Project Gutenberg, if you've ever heard, code repos like GitHub, math, you know, papers, that kind of stuff, YouTube transcripts. So guessing the next word is super powerful when an LLM is training on factuality and common sense, because then when we're talking to it, it seems like magic. It seems human, but it really isn't. It's because it's just trained and has humans given feedback to another model to help it improve. And then you can imagine, the larger the compute, the larger the data set, the larger what they call the parameters, the outputs get a lot better. And so you'll see some of these large language models checkpointed at different sizes, you know, 7 billion parameters, 15 billion parameters, 30 billion, so on and so forth. Right. And I often hear that, oh, large language models are new in the media and all that stuff. Really, it's basically an evolution of technologies that have been around since the 60s. And so this is natural language processing to a complete, to the nth value, because the amount of data that it's being trained on is a lot larger these days, right? So these transformer models are the state of the art, and I'm going to sort of fast track this a little bit and move to some of the meaty stuff. Why do they behave the way they do? Three core areas: probability, meaning, there's this, like I talk about, they're stochastic, they're random in nature. And so they might not behave like you expect every time. You can ask a prompt in two different ways, you'll get two different answers. Knowledge gaps. ChatGPT famously talks about how they stopped training in September 2021. And of course, overfitting means Sarah Silverman, the comedian, can now sue, because when you type in a prompt a specific way, an entire excerpt of her book comes out. And that's just a result of overfitting. Okay. All right. So I'm running out of time. I didn't realize 30 minutes goes by so fast. And so over here, I'm going to just say where we check for issues are in the data, our data inputs, while we are training and evaluating, and also if you have the resources to do reinforcement learning with human feedback or other methods in order to sort of ensure accuracy in your systems. It's actually a whole lot more to improve the quality and reliability of your models. Prompt engineering, RAG, or retrieval augmented generation, you've probably heard of, fine tuning, and so on and so forth. And so I'm going to skip this slide. Sorry. This is a generalization, but from what I see, when I say trustworthy AI in terms of generative AI, we're looking at accuracy, we're looking at bias issues, consistency, interpretability, meaning explaining why a thing happened, and completeness. In the enterprise, these are some of the use cases that we care about: information retrieval, automation, content generation. And with that, I wanted to sort of share one such use case with more by fine-tuning a large language model on a publicly available data set from the United States Department of Health and Centers for Medicare and Medicaid. So here, I'm not going to run this because these things take time. Here, and I'll make these slides and this notebook available in case you want to sort of try a different data set, and definitely reach out if you need this. Here, I'm basically categorizing based on, well, let me take a beat. What am I trying to do here? So basically, to help improve decision-making for Centers for Medicare and Medicaid practitioners, or even providers, we may want to know which hospitals around the country are top performers around a specific illness. In this case, I'm talking about COPD, right? And so I sort of analyzed my data. I pulled this from Kaggle. It's also on BigQuery. I analyzed my data. I do the traditional narrow AI or traditional machine learning approach by understanding what data I have, analyzing that, splitting that into a train and test set so I can actually see how well it generalizes. Thanks to the fine folks at Hugging Face, I'm able to, get a model, basically Llama 2, that is optimized for running on a GPU or even a CPU. I'm paying for Colab for the sake of this demo, but you probably don't have to. here. And so this is the Llama 2 7 billion checkpointed model. You probably don't care about all of that. And so let's go into text generation. So first, what I want to do, like I mentioned before, is I want to analyze COPD. So that COPD, for those who don't know, is chronic obstructive pulmonary disease. And this is available in the data set that I'm loading. And I'm going to be fine-tuning against this. And so I want to sort of predict and summarize information related to the percentage of obstructive of COPD, and then sort of classify that summary and prediction into a performance tier. Like you saw above, it's either, top performing, underperforming, into those categories, okay? And when I test, I give Llama AI, the Llama 2, the prompt directly. I see some interesting things happen. If it's hard to see, I can actually zoom in a little bit. So I ask it, give me, your, based on the number of visits, the percentage of COPD reported in a given location, predict and classify the performance tier. And it does well, but then it starts speaking German at some point. And so it's unpredictable, it's unreliable, right? Same thing if you want to just, zero shot it and basically just ask a ChatGPT or the API. And I famously asked it, who won the 2020 relay race in the Olympics, and it gives me a Jamaican lady, which is great, but unfortunately that never really happened because there was a pandemic during that time. So the point is, it doesn't happen. And so here I start saying, I don't have the resources or the money to fine tune on, NVIDIA A100 GPUs. And so the fine folks at Microsoft and I forget the university came up with something called PEFT, parameter efficient fine tuning. And what that's doing here is, again, optimizing, adapting the weights of that large language, the Llama 2 language model, so that I can actually run it on, smaller compute, right? So I load my trainer, and I'm going to fast track here, and I train, just because of time, train my model. I'm teasing you guys. I'm just going to get right into the demo. And with the model now fine-tuned after I trained it, I can actually just look at generated text on a given prompt, a similar prompt, and I start seeing actual data from that BigQuery data set or that Kaggle data set, just raw data from it. Okay. And then I'm going to take that a step further and start analyzing a couple features of that data set. And here, once I spit it out, evaluating this data set, I'm able to get predictions on the performance on some of these agencies around the nation, around the United States. And it's classifying each one of these somewhat accurately. Again, we've got we split our data into train and test. And so we wanted to sort of test that out. Here I'm using weights and biases, one last thing, in order to further evaluate the model. We don't have time to jump right into that, but what you always want to do with these models after, especially when you fine tune it, you want to look at the outputs. Remember before we looked at the outputs while we asked the language model, or we queried the language model for a specific input with a specific input. Use that as your ground truth. Do the same thing with a fine-tuned model and sort of compare the two essentially. And so that's sort of the final sort of step that you want to do. There are ways to evaluate this and visualize these models. And again, I don't have time to get into the minutia and all those details. But again, when you're working in an enterprise, I don't care your industry, especially if you're working with consumers or you're working with other businesses, or even within your own inbound, within your own organization, you want to trust that the models that you're working with are factual, trustworthy, and not harmful, right? And so whether you're doing chatbots or customer service automation, or just creative writing of a marketing company, fine tuning on your own proprietary data set is one way to increase reliability on these systems. But there's some bad news. All of those methods that I've just mentioned, I want to leave you on this, don't really guarantee reliability. And so today, thank you. We've gone over how they work, how large language models work, why they're unreliable, ways that we try to mitigate. I've shown you one way, which is fine tuning. And, the key takeaway is that even that doesn't guarantee everything is going to work. So welcome, thank you, and I hope you enjoyed the first annual Llamas. I don't see any questions. So I think I'm going to hang up and hand off to the next person. Thank you, everyone, for joining.